can start. So welcome to the session, the state of code coverage for Kotlin. So today we're going to talk about code coverage, as you might have guessed. And first of all, let us introduce ourselves. So I'm happy to introduce my colleague Evgeny Mandrikov, who is principal software engineer at Sonar. And he's also JCoco project co-lead. And today he's going to be responsible for the code coverage part of our talk.
And I'm happy to introduce my colleague, Margarita. She's staff software engineer at Sonar. She's also Kotlin Google developer expert. You could find her on Twitter, on GitHub, etc. So today she's going to be responsible for the Kotlin part of our talk, as I am not at all a Kotlin expert. And before we start, we should do some disclaimer. We work in a great company, Sonar. By the way, let me check who knows this company, who knows our products. SonarQube, SonarLint, SonarCloud. You might hate them, you might love them. We don't really care today. We're not going to talk about these products. We're going to talk about something else. We're going to talk about, let's say, our nightly job outside of working hours. So whatever we're going to tell you today is our own opinion, and the company has nothing to do with it.
And there is one more thing that you should know about me. I'm Ukrainian. I was born and raised in Kyiv. And today you might heard that my country is struggling. We have huge problems with our closest neighbors. And today Ukrainians need all the support that the world can provide. So if you feel like you want to support Ukraine, here is a link for a trusted charity fund. So feel free to scan it and make some donation. And Ukrainians will really appreciate this. So the most important and the most serious part of the talk is done. Now let's have some fun.
Well, apparently I'm also going to be responsible today for the fun part of this talk, as
no,
Margarita is done.
We all are doomed here then.
If I am doing a fun part. Yeah. Let's see. So let's start from a simple question. Margarita, what is code coverage?
I think what Wikipedia says about this you can read here, but I'll just try to tell you in my own words. For me, code coverage is a metric that can help you identify which part of your code was executed when you executed tests. So in my team, we like code coverage. We use it every day. And code coverage helps us a lot to identify which branches were not covered, what was not executed. And sometimes it even helps us to identify bugs. So some time ago, this is actually the project one of the projects that we maintain in my team. It's static code analyzer for Kotlin. You might use it if you use Sonar products. And it was written in another engine. It was written in Java. And a long time ago, we decided to rewrite it in Kotlin. And guess what happened? We observed some interesting outcome. Previously, we kept, what is the level of code coverage you try to target? Like, maybe raise your hands if it's 60%,
too low.
70, 80, 90, 100, maybe 120.
Yeah, that's a wonderful one.
So actually, in my team, for some reason, we try to target 95%. And actually, it was not that difficult to achieve. And if it's not 95%, usually it means that you haven't covered something and you can find bugs. But once we rewrote everything in Kotlin, we could not actually make 95%. We had to lower the target to 85%. And today we're going to learn why this happened and what actually is behind code coverage for Kotlin.
So for today, we're going to talk about some tools that exist for code coverage in Kotlin. And tools for code coverage in Java JVM world, they've been known for nearly 2 decades, even more. If you're as old as me, you might remember Emma back to 2003. Emma was actually released, I think, just once and never anymore. It was actually used in Android SDK quite some time ago, before it was replaced in Android SDK by JCoco. There was another tool, Cobertura. It's also not maintained anymore nowadays. So probably that's not the tools we're going to talk today about, but let's move on. The reason there was some other tools like source-based Clover. It later became Open Clover. It was commercial product by Atlassian. It's also not very interesting to us because it really claims that it's Java only because it works on the source code. Then, well, we got Android 1.0 in 2008. Time goes on. In 2009, there is a rise of new code coverage tools. In particular, that's the first commit into the Jacoco project. It's the first commit in JetBrains coverage engine used in IntelliJ IDEA. And there is a first commit in a so-called ptest2. Time goes on. In Jacoco, we had a support for Android. Android is still not Kotlin-based because Kotlin not even yet released. Time goes on, and in 2016, we get a Kotlin. All those tools except Clover, they are not source-based, they are bytecode-based. So everything what is capable of compiling into the bytecode, for all of this, our bytecode-based tools should work, right? They're bytecode-based, here is a bytecode, they should work. Actually, it turns out to be not really true, because we do some changes to support Kotlin in Jacoco. The same happens with JetBrains coverage engine, the same happens with the ptest, and that's probably what we should be looking today. But there is one more thing to mention. In 2021, JetBrains announces Cover, like a wonderful tool for code coverage in Kotlin. That's partially true, partially not, because Cover is not more than just a Gradle plugin. Cover under the hood allows you to use Jacoco for Kotlin and allows you to use JetBrains coverage engine for Kotlin. That's it. It's not a new tool. It's just a Gradle plugin. And here we come to the present time. So what we will be looking today, Margarita? Of course, I cannot skip Jacoco as I'm one of the maintainers. Today we're going to talk about Jacoco. Here we have a simple, stupid hello world example with one branch with some test. In this test, we try to test both conditions of this branch. We execute this test, and Jacoco shows us, yes, every line is green, everything was executed, and here is, I hope you can see, all two branches covered. Jacoco provides some nice metrics, like how many lines we covered, how many lines we missed, branches, the same, and instruction coverage. So that's my tool of...
Pikachu will represent Jacoco as far as I understand.
Why not? Okay, Pikachu is going to represent Jacoco.
So,
what else do you want to pick?
Of course, it would not be fair to talk about code coverage, the state of code coverage, and not talk about JetBrains coverage engine. So the other tool that I suggest is JetBrains coverage engine. And you can see that a report looks pretty similar to Jacoco. Everything is green here, and you can see that there are method, branch, line, instruction coverage. So everything is there. And here are some GitHub links where you can find the source code.
I'm not really in the world of Pokemons. Who is going to represent?
It's Bulbasaur.
Bulbasaur, okay. You should remember, or
because...
you should know.
Yeah.
I think 2 is not enough. Let's pick a third one. Can I pick?
Yes.
And today we're going to talk about a third one, which is ptest. It's not really code coverage engine. It's a little bit more than that. It measures code coverage. So here you can see green lines. This is the lines that were executed, and the red line also was executed during execution of tests. But ptest provides even more. Ptest provides mutation testing. First, it measures code coverage to understand which tests correspond to which code, and then it starts modifying the code. For every code modification, so-called mutant, it runs associated tests. If the test succeeded even after the code modification, it says, well, mutant survived. And this is bad, because test is probably not testing what it's supposed to test. And, well, if test failed, then mutant was killed, which is good, and test is good. So in this particular example, we can see that all other code coverage engines, they say that everything is covered, everything is fine, but ptest, thanks to the mutation testing, says that, well, if we remove conditional and we replace equality checks, then mutant is going to survive. And this points out that we actually forgot an assert for the first branch. So who is this Pokemon?
This is Charmander.
Okay, Charmander is going to be ptest. Are you ready for the comparison?
Yeah, actually, I think yes. The only problem, I don't know how to compare them, because like they're so different and they're so the same, but I've never compared tools like this, so maybe you have any idea how we can compare them?
I never compared as well. This is my first time we're trying to do this comparison, but I suggest something pretty simple, pretty stupid. Let's just go through some language features and try to see how those tools behave with them. And let me propose, try with resources. Every Kotlin developer should know Java try with resources, right?
Okay.
Let's try it, right?
Let's try.
So I have a Java code here. There is a resource file input stream. I open it, I read something from it, I return value. Pretty simple, right? And I can write a test for this simple code that actually this code able to read something from def random. Why not?
Yeah. Now you could have static imports.
What? Yeah, I could have static imports. Okay, sorry. Let's go on. So I run Jacko code. Jacko provides me this report. Everything is green, everything is covered. Pretty neat, pretty nice. It works for try with resources.
Yeah.
I run JetBrains coverage engine. It also says everything is green, everything is covered, everything is fine.
Stop. What are you saying?
Everything is green, everything is covered,
You guys see
100%
it?
coverage.
No. Look, first of all, the line 10 is yellow. And on the branch coverage, you can see that there is 25%.
No, line 10 is green.
Yes, but 25%.
Oh, yeah, you're right, 25%.
Oh, sorry, I always forget that he's colorblind.
Oh.
So technically, that's...
Who else has difficulties with this?
I
always have difficulties with this, and I always have difficulties with even Jacko code coverage reports. They also show yellow, and it's pretty hard for me to distinguish.
Actually, it could be one of the points how to compare tools, how colorblind friendly they are. And I guess all tools are not really good with colorblind UI. But here, the line is yellow, so it means it's not fully covered, and the branch coverage is 25%.
But what else to test here? Can you imagine?
Yeah, I guess
Any
this
ideas?
is a false positive.
Exception. Okay, we're going to see probably later. I'm going to provide explanation. But before we provide explanation, let's have a look on p-test, right?
Yeah, let's look at the p-test.
P-test is also fine with that.
So
I hope. It's all green here, right? No yellow. Okay, fine. So, explanations. All those tools are bytecode based. So to get an explanation, we have to look into the bytecode. Let's have a look. That's my favorite tool. Another one, Java P, part of GDK. It's basically showing you text representation of the bytecode. With two arguments, -v verbose, -p shows the privates. And I provide class name. So we're going to get the bytecode. And now that we look at the bytecode, it should be pretty obvious what we forgot to test, right?
Okay, so you cannot distinguish green and yellow, but you can read here.
Yeah, I can read bytecode. It's, I need to zoom. Sorry, guys. Okay, is it better?
A little bit, but still.
I should
You're a bytecode expert here. So.
I should explain. Okay, let me explain. So, oops. Let's look precisely on those lines in the bytecode. There is some null checks. There is some invocations of close method. Actually, there is two null checks and two close methods. And the fun part is the ones who guessed that we need to test exceptional pass, they're right. That's one of the null checks and one of the close methods. It's corresponding to the exceptional pass. So if we will throw exception, we will hit those branches. But unfortunately, that's not enough to get a 100% coverage because the compiler generated null checks in case if resource is null, which never happens in our code. So this code is simply not reachable. It's not possible to write a test. And to fight with that, well, either you accept not 100% coverage, which is not nice. Either we developers of a tools should write the filters, meaning that, well, try with resources generates what it generates. You don't need to test the compiler. Test your code, not what compiler generates. So all the compiler generated code should be hidden from you. It's right by definition, it's compiler generated. And that's what we do in Jacko. That's what is happening in p-test. Unfortunately, that's what's not happening for this example in JetBrains coverage engine. But well, that's fine, that happens.
Yeah, okay, thanks for this example. But have you noticed something like fishy here or strange? Like we are talking about the state of code coverage for Kotlin, aren't we?
Come on, I'm a Java guy.
Okay, I'm a Kotlin girl, so let's pick up something else. Do you have any different example.
What about when expression by a string type? Is
Okay,
it
let's try
Kotlin?
this.
Okay,
Let's start
let's
with
do
this.
it. Can you write?
Yeah, I'll do. I can write my virtual keyboard. Here it is. So I wrote some code. It's a stupid simple one expression with 3 branches and 1 else, so 4 branches. And I think I wrote 4 tests, like 4 sorts. And everything is covered here, yes?
Let's check. Like there is 4 branches, 4 assertions. Who agree? Like, I
Yeah, it
think
should.
so.
So I expect 100%, but let's try. So, okay, GCoco says it's 100%. Good for them. JetBrains coverage engine shows. No, it also shows 100%.
But hold on. This time I look not on the colors, I look on the numbers, as you suggested me,
Yeah.
right? Like, okay. What's that? Like 3 branches here?
I don't know.
Well, okay.
There anybody from JetBrains
maybe
here?
they filter it out a little bit more, or maybe they count somehow differently, but for some reason they
But who
show.
cares? It's still green. 100%.
Okay, it's green. 100. Let's move on.
Yeah, so 100 green. So
P-test?
and p-test, something strange. So it says that all the branches were executed, but when itself was not. So let's maybe have a look. There are some mutations that survived. So replaced 3 equality checks with false, and they survived. So I don't think I understand what's going on here. Apparently there is something in bytecode, but maybe you can explain more.
Yeah, notice that there is multiple mutations. There is change at a switch default to be the first case. So there is a switch. And then it also says replaced equality check. So there is some equality checks, which is pretty weird, right? Let's look into the bytecode. Okay, this time I straight zoom in. So here is a bytecode. Indeed, here we can see a switch. But this switch is done by hashcode. Turns out that for performance reasons, it's quite efficient to implement switch by a string or when expression by a string as a switch by hashcode. With high probability, we're already gonna pick a correct branch. Unfortunately, we all know that different strings can have the same hashcode. So we also need to do the equality check after we did a switch by hashcode. And that's exactly what p-test reports as uncovered things. Margarita tested strings with a different hashcodes corresponding to all the possible switch cases, but she forgot to test strings which have the same hashcode.
Come on, should I?
No, you shouldn't. It's again compiler artifact. We shouldn't be testing that. We should do the functional testing. So this should be filtered out.
Okay.
JetBrains did well. JCoco did well. p-test did not, but I have a good news for you guys. There is actually, let's say, a force tool or extension for the p-test, commercial extension for p-test, which claims to provide better results for Kotlin. And it's called arcmutate. If we use an exactly same example, arcmutate, here is the report that we are going to get, also 100% coverage.
So with enough money, we can transform our Charmander into Charizard. So it was a good example. However, I think we need something really Kotlinish because like when expression, it exists as switch in Java. It's not true Kotlin feature. So let's try something.
So you're not going to let me choose anymore?
No, I think this time I should pick up
okay.
the cases because
okay.
you're picking everything for Java.
Okay.
So how about inline functions? I prepared this example where is inline, stupid simple inline function with lambda, and I wrote a test to test it. So honestly, I don't know what else to test here. So apparently everything is covered here, and I expect 100%. Let's try in JCoco. Oops.
Doesn't work.
Like it doesn't work. So the test was executed, assertion was executed, but not the lambda, not the function itself. That's a bit strange, but maybe before digging into this, let's check JetBrains coverage engine. Oh, JetBrains coverage engine shows everything is green. So we already have some differences. And for arcmutate, unfortunately, I was not able to generate.
For the JCoco, isn't it obvious? Like JCoco developed by me. I'm a Java guy. It's a Kotlin code. So
but you claim
really
that you're able to support for Kotlin.
Yeah.
So
yeah,
there
indeed.
is no report from argmutate, and I
Which
don't know
supposed
why.
to provide coverage
and
for
it's
Kotlin, right?
Yeah. So maybe you can help me with that.
Look, you're a Kotlin expert, but code that you wrote, sorry, it's way too simple. It probably doesn't require any test to be written, and that's what argmutate tells you. Like, you don't need to test this code, right?
Okay.
Can we complexify it a little bit? Like, can you make, well, you have a lambda. Make a return type nullable.
Okay, I'll use my virtual keyboard. And here it is. The return type is now nullable. And I added another test with null to check that everything is completely
You also
covered.
added another thing, right?
Which one? I added the return
Null
type.
save call operator. I don't know why I know this in Kotlin, but well.
Come on.
Okay.
Otherwise, it won't compile. So yeah. So I added another test. I added return type. So let's try. I think we don't need to test JCoco because it didn't work on the previous example. I don't think it's going to work here. So for the JetBrains coverage engine, whoops, looks like we broke IntelliJ coverage engine as well.
Can you see it? I guess it's yellow for you, right? And
Yes.
the branches coverage is 0.
So we
Pretty
have,
weird, right?
yes, I think I covered everything. And
let's check
still no report from argmutate, and I think my clicker is not working.
No, it's working. I just click faster.
Okay. So maybe you can help again?
Yes,
as
well,
a coverage expert.
Inline functions, as name suggests, they do inline. Actually, the body of inline function is not going to be executed. Compiler is going to put the body of inline function into the every call site where this inline function is used. So
what can we do for this?
To show what happens and why, etc., can you do one more code modification? Could you please extract call sites from your test into the main code?
Okay, I think I can. It doesn't seem very difficult for a Kotlin Google developer expert. So yeah, here it is, and I think they're still same. So the tests are still the same. So let's run again our test tools. So the JetBrains coverage engine is still showing that nothing is covered in branches, and we finally have a report from argmutate, and it's all green.
So do you still need explanations?
Yeah, I think I want to know what's under the hood.
So argmutate, as I said, it mutates not your tests, it mutates your code. And duplicates or inlined body of inline function, they all have been in the tests. Argmutate mutates original code, but this original code is never executed by tests. So no report there. And we need to get explanation about missing branches and absence of coverage in JCoco. So let's have a look at the bait code. Here is our original body, which is never executed. There is indeed a null check corresponding to the null save call operator. It exists in the original. And then if we look at the first call site, we're not going to see any null check there. So not only inlining happens by the compiler, there is also some optimizations. Like there is no more lambda anymore. Like that's a wonderful part of inline functions. They remove overhead of lambdas passed as parameters. Also, optimizer can kill some null checks or constant fold some constant expressions. And that's what makes it hard for code coverage tools to work. It's actually not anymore possible to map this bytecode back to its original source. It's different from the original. Here is a call site 2. The same happens there. There is no null check anymore. That's why JetBrains coverage engine is partially able to map both call sites back to the original, but it's not able to map branches because the branches disappeared during inline.
Okay, let's. I like this, but I think we need another example to test. It's Coroutines, because like it's 2024, it's almost Kotlin 2.0. Are you guys waiting for Kotlin 2.0? And we cannot imagine Kotlin today without Coroutines. And do you remember when Coroutines appeared? Like, I think it was
end of 2016, because I was using in 2017.
Yeah, so it was Kotlin 1.1, I guess. Yeah.
Or 1.2.
Yeah.
Does it matter?
No. Okay, so it's pretty old, one of the oldest features and one of the greatest features of Kotlin. So of course we have to test it. So here's my example. I like this example of generating Fibonacci sequence with coroutines and the yield method. So I wrote some tests for this. I think that's enough actually to test the whole body of this method. So let's try to run some tools. Jacob says that everything is covered.
Yay!
Okay, good for you. And JetBrains coverage engine is also great. So, and what about ArcMate? Oh,
It was supposed to work for Kotlin, right?
Yeah.
And you said Coroutines is quite old Kotlin feature, right?
So seems like even some amount of money cannot help here. So unfortunately, there are some mutants that survived. And I do think that it's something similar. So I think we're not going to look at the bytecode, and it's more of your home task if you want to look in the bytecode of what's happening there and what is not covered. The story is probably the same. There could be some additional conditions, additional branches that just this tool is not filtering out, while Jacob and JetBrains coverage engine are filtering them. So
we are not really running out of the time, but we are forgetting one important thing.
Which one?
Well, we are on a conference for Android developers, and we haven't talked about Android today at all.
Actually, haven't told that neither of us are Android developers.
Well, don't tell this to anybody, otherwise my imposter syndrome skyrockets.
So, okay, indeed, I have something for you. So there is a really cool framework, which is Compose. Maybe you raise your hands if you're using Compose already.
Oof.
Wow, a lot of hands.
Can we do the other way around? Who is not using Compose? Nobody. Okay.
But still, there was half of the room that didn't raise their hand.
No. They all raised.
So okay, Compose. Everybody is using Compose. So let's check how the code coverage behaves on Compose. Here's my stupid simple example of composable function.
And that's probably why you are not an Android developer, right?
Yeah.
It probably doesn't make much sense to write a composable function like this, right? Yeah. But okay, whatever.
Yeah, but let's start with this. So, and let's write some test. Okay. And Jacob seems to report strange stuff. It says that body of if was executed, but not the function itself.
Well, not the first line of the function.
So, okay.
But okay, can your JetBrains coverage engine do better?
Mine, I'm not developing
it. Okay, not your JetBrains coverage engine. Can it do better?
Looks like it shows pretty much the same.
Okay, can what ArcMate do better?
I don't know, but it claims support for Kotlin. Who knows? Okay, I think it's pretty much the same.
So every Android developer wants coverage for composable functions, and there is no tool that provides that, right?
Looks like this.
Yeah. We should fix that. And actually, yesterday night, I spent some time not in a bed, but writing something here and something there. So I got a good news for you today. If you will run a Jacoco work in progress branch, actually, it's a snapshot version made yesterday. That's what we're going to see. Pretty neat, right?
So it's still broken for release, but you guys can expect
hopefully we can do release soon.
Yeah.
Maybe I shouldn't be at the conference. Maybe I should be doing release,
and
people will be much more happier.
So you see, the reason why you are not getting things covered in Jacoco is because he is doing conferences instead of writing. So,
do you have something else? I think we forgot another thing.
Really?
Sorry, not Android related. Yes, we talked a lot about correctness of code coverage reports. That's a neat thing, but let me remind you a thing from physics, observer effect. Every time you observe something, just the fact of observation is going to change what you observe. So, and code coverage tools, they're not exception. By observing, by spying on what your code does, they might change what your code does. And this is bad, right? because they're supposed to help to test your code, but if they're changing it, it's dangerous. Maybe you're not testing anymore what you're supposed to be testing. And let me give you, sorry again, kind of Javish, or I think you could write the same. No, not I think. You could write the same in Kotlin. You could write synchronized inside of a try-catch block. And everything is good with that. Compilers are good with that. They're going to compile this. And code coverage engines are good with that. They're going to transform the result of compilation of this. And all this works according to the specification. And Java Virtual Machine specification in particular contains a paragraph about structured locking. Basically, compilers and tools, they should obey some rules so that locking and synchronization blocks works correctly. And all good, all tools, they look at the compiler output, they adopt it to the compiler output, and they still preserve this structured locking property even though they modify the bytecode. All was good till R8 shrinker appeared. You might know this one because I think it's part of Android SDK. It's used to shrink your program so that it takes less space. And this tool is also good. It changes the bytecode, but in a way that the property is still preserved. What's interesting is that if we will apply code coverage tool on the result of R8 shrinker, then the property is going to be broken. We will see this, we can see this with all the tools we are showing you today. They all provide broken program after shrinking. If you will run such a program on a hotspot JVM with some debug options like print compilation and please log me the problems with monitors, we are going to actually see that hotspot JVM is going to refuse to JIT compile this try-catch block.
But this is hotspot one. So
it's hotspot. Your program is still going to work, but it's not going to work at a full speed.
Okay. But
what's worse, yes, it still works. But what's worse is that Android runtime completely rejects to run such programs. It's like going to say, no way. I'm not going to run this. It's not safe. On the Android device or Android emulator, this is not a good thing to do.
Okay, that's sad. And
that said,
also reminded me of another outcome of observer effect.
Before you go to the another one, interesting thing, our usual answer in the user's mailing list would be, well, it's just one stupid corner case. You can rewrite this code slightly differently so that you are not stepping on this problem. But if you can't rewrite this code or it comes from a third-party library, then please just exclude the class and everything should work. Unfortunately, the problem is for integration with Android, you cannot tell, please exclude the class. Android is going to instrument all this for code coverage, instrument everything. This is a little bit out of our control. We cannot do with this, well, we can fix original issue. It's not that simple, but workaround on our site we cannot provide. The best, in my opinion, workaround would be in the Android SDK, in Android Gradle plugin, to provide an option to exclude some parts of the code base, like third-party classes or even some of your classes, from code coverage instrumentation. This is not yet there, even though this integration exists for many years, but there is at least a ticket. If you're interested, I could give you this ticket later, or you can Google it and find it, and please vote for it so that it gets implemented.
Yeah, thanks for saying this. I think that's really important. And another thing, another effect, outcome of observer effect is performance. Because all these tools, they do some overhead. They provide some overhead, and it means it affects your performance.
Are you sure they provide some overhead?
Of course, like, come on. They're
Maybe
taking
it's
modification.
a small one?
Let's test it. So what I did, I used all the three tools on the project that I maintain, Sonar Kotlin, and here are the outcomes. So raw tests take 57 seconds on my personal machine. With JCoco, it takes 1 minute, 20 seconds. With JetBrains Coverage Engine, it takes 1 minute, 23 seconds. And with speed test, it takes 1 hour, 20 minutes, 7 seconds.
No. Hold on, don't be so sad. It's initial run. It's initial run of p-test. indeed, we need to mutate a lot of code and run tests many, many times. But this initial run, you can tune p-test so that it takes less time. It can keep the history, so if you're modifying your code, you don't need to rerun the tests that you're not touching, that you're not modifying.
You mean they can work incrementally?
They can work incrementally. Moreover, you don't need to run this on your developer machine. Come on, you have a CI servers, which are much more powerful machines, and you can do the nightly job. And 1 hour during the night when you're sleeping, it's like nothing, okay?
Yeah, I think for nightly build, it should be absolutely fine if I
Indeed,
don't care,
there
but
is,
not locally.
there is initial cost and quite high cost to configure all this and put in place, but maybe it could pay off. So don't reject this option from the beginning, all right?
You see, mutation test takes quite long, but it also provides you more information than just code coverage. And with gCoco and JetBrains coverage engine, looks like they're pretty much the same, so they're on par.
Wait a second. So, like, can I take a microscope and look at this more precisely?
So you want to write a micro benchmark?
Yes, I want to write a micro benchmark. So
okay, go ahead.
Here is your favorite example, Fibonacci numbers. If we run this non-instrumented, instrumented by gCoco and instrumented by JetBrains coverage engine using Java microbenchmark harness, that's what we are going to actually see. Original, able to produce about 1,300 and something operations in microsecond, which is, well, normal. Our experiment makes sense because no operation, if you measure doing nothing, it's faster. So indeed, we executed some code that probably computes the Fibonacci number. Correctness, we tested earlier. Margarita is able to write a test for this. We look at gCoco. Well, it is slower. It's not significantly slower, but yes, there is some overhead. And if you look at the JetBrains coverage engine, it's almost 2 times slower than the original. So be careful. Depends on what kind of application you're writing, depending on what kind of computations you're doing, the impact might be either not observable and you wouldn't see the difference between gCoco and JetBrains, or it might be actually,
like this.
Why not twice time bigger?
And I think it also tells us a bit that what's under the hood of these tools and exactly how you're counting code coverage and how this tool is counting code coverage. So like probably they put probes in different places. But okay, I think we talked about the performance a little bit. So
is there something else?
Yeah,
I guess we're pretty close to the end of the time, so let's do the final comparison.
Yes, let's do it. So, of course, there are much more examples than we showed you today, but we are short on time. We showed you only the most interesting, like to try to show you that every tool has their pros and cons. Here you can see that all the tools are pretty much on the same level. So something is supporting some is better, some support of other features in other tool is better. So, and somewhere it's worse. But in general, they're pretty much the same. So
the list is probably not complete. Yeah. That's just what we came up with.
And that's what we came up with. And of course, there could be much more examples. And what we wanted to tell you that this is the current state. And the future that we all would like to see, that all these tools are green, that they fix all these problems and the code coverage is perfect everywhere. The performance is great. Everything is great.
They cannot fix code coverage. They can fix the result of computation of code coverage, but
yeah, I mean, not your code coverage.
You should fix the code coverage and your tests.
We had this idea to, like, with generative AI to generate tests for you and make your code coverage with 100%. But yeah, so that's what the future is bright, and we expect everything to be green here.
We started work on something. Where we can, we started work.
Yes, and you can see that we can tell about gCoco where something started, or the work has started. I think there is probably much more in JetBrains side, so they're also working on improving the code coverage there.
Well, actually, we have some form of collaboration. Hopefully, they will also catch up, maybe looking on us or maybe looking on our back reports or whatever. we had a collaboration in a sense that we constantly test a beta version of Kotlin compiler, and sometimes it happens that we report them bugs so that they fix the Kotlin compiler, and it happens the other way around. Actually, the very first contribution to support Kotlin in Jacoco was done by a person from JetBrains. He came up to us with the idea how we can distinguish some parts of the code, and we just helped him to implement this idea.
So this leads us to some conclusions here. So first of all, as you might have noticed during our presentations, tools are not ideal, and we have to deal with this, but they're still helpful. Even in the state that we have now, they still provide some coverage, they still tell you what is not covered, and even while you're investigating the issues, the false positives, you learn something new. So they're helpful, and what's the most important, they're not fighting against each other, they're all fighting on the bright side against the bad quality of your code and against bad tests, trying to help you to write better code and to make the world better. So don't hesitate to provide feedback if something is not working, contact maintainers, provide GitHub issues, and report these issues, because that's the way how we can improve the state that we have now. And let's be nice to each other, because as you might have learned today, it's not that easy to write a code coverage tool, but all the maintainers are doing their best to do it. So I think that's it. So thank you for coming.